Hello, class. I am your instructor today, Mr. Hoffman, and we will be going over fluoroscopy. It's quite an exciting subject. What's covered today? Fluoroscopy being a dynamic image using a automatic brightness control. Has to do with image intensifier, flux gain, brightness gain, magnification gain. And Sonia is interrupting my presentation. Thank you very much. I'm going to have to put her on mute real fast. Wish I could do that in class. I'm just kidding, just kidding. Fluoroscopy also has to do with magnification, image quality, and a mobile fluoroscopy. At the bottom of the screen you'll see a typical fluoroscope that's probably in one of your fluoro rooms at your department. Right under here is where the tube would be, patient, and image intensifier on top. Thomas Edison invented the fluoroscope in 1896. The most common setup for a fluoroscope, like I said, the X-ray tube is under the patient and the image intensifier is above. The image intensifier receives an X-ray beam and converts it into high sensitivity, high intensity visible light. Image intensifier components. A is the input phosphor goes into the cathode, then it's into the focusing lenses, into the anode, and out through the output phosphor. Going over some of the image intensifier components. We have the input phosphor, which is made of cesium iodide, and it takes X-rays and converts it into light. Then it goes into the photocathode, which is made up of cesium antimony. It absorbs light and emits electrons. The electrons travel through the image intensifier up to the anode through the electrostatic lenses, which are negatively charged, pushes the electrons towards the center and towards the anode and output intensifier. The anode is positively charged, and which leads us into the output phosphor, which is made of zinc cadmium sulfide and converts the electrons back into light photons. Magnification versus image brightness. When an image intensifier tube is switched to magnification mode, less of the input phosphor is utilized, a smaller field of view. The result is fewer electrons start striking the output phosphor, resulting in a darker image. All other factors are unchanged. Magnification formula is input screen diameter divided by input screen diameter during magnification. Magnification versus image brightness. To correct for loss of brightness, the X-ray generator increases MA, permitting for more electrons to be generated. The trade-off, however, is increased patient and occupational dose. Magnification advantages are better spatial resolution and better contrast resolution. The measure of image intensifier efficiency. This is the image intensifier's ability to convert X-rays into light, are measured by magnification gain and flux gain. Magnification gain is increased brightness due to the same number of light photons being concentrated into a smaller area, or the output phosphor. Magnification gain is input diameter squared divided by output diameter squared. Flux gain is the number of input light photons divided by the number of input X-ray photons. So essentially it's output over input. The ability of the image intensifier to increase the illumination level of the image is termed brightness gain. Brightness gain formula is magnification gain times flux gain. The range of brightness gain for most intensifiers is 5,000 to 30,000. On that note, throughout the presentation you'll see some of the items have been highlighted in red that may be some information you might want to write down or commit to memory. Hint, hint. Veil glare is the internal scatter that reduces contrast of the image, and vignetting is reduction in brightness at the periphery, which is the sides of the image. Because of its high efficiency, the fluoroscopic current on image intensifier systems is less than or equal to 5 mA. This permits a lower patient dose per unit of time. However, prolonged use of fluoroscopy during procedures may actually increase patient dose compared to a routine overhead imaging. And this plus or minus, or this less than or equal to 5 mA should be in red, just in case you guys needed to know that, which you do. The automatic brightness control is a portion of the fluoroscopy circuit that maintains image brightness where there are changes in body thickness. The ABC maintains the brightness of an image by varying the kVp and MA. What we have here is a mobile C-arm, which I'm sure you guys have used before. They have certain ways of hooking this up. So what our departments normally do is from the monitoring system here, you plug in, which is this cord here, the C-arm first, then you come back to the monitor, plug in the monitor, then turn it on. Boop, that button right there. Once you're complete, do everything in reverse. So you'll essentially shut the machine off, unplug it, and then unplug the C-arm. And you have some adjustments on the C-arm. You have a horizontal adjustment, which is back here, it's called the wig-wag, so it goes side to side. You have an orbital adjustment, which is right here, it's like the rainbow adjustment, goes up and over and under. A vertical adjustment right here goes up and down. The two up and down buttons are right there. The C-arm rotation, which is in this general area, allows you to rotate the C-arm on this axis right here. And they have a in and out function, which is this release right here. It allows you to push the C-arm in and out. I don't know what this is, 15 or 20 centimeters or inches. Can't remember exactly which one that is. That's about it for this mobile fluoroscopy, except that it does have this pedal that you're allowed to fluoro certain things. Some doctors like the control of having the foot pedal and allow them to see what they want. So if they want that, set everything up as normal, throw the pedal down there, sit back and let them fluoro, keep your distance, and then adjustments as needed, however their instructions are. And that's about it. Fluoroscopy is fun. Either this is a tech that has a sad face, or his face is covered by a sweet Fu Manchu mustache. I'm not quite sure. Trying to leave off on a positive note. Have a super day, everybody. And the test will follow per Kayla's instructions. Alright, take care.